Hi everyone, welcome to day 3 challenge. Today we're gonna do the 3 hardest question number 5. The answers are D, D, and B. Did you get them correct? Alright, let's get started. The first one, what is the greatest number of consecutive integers whose sum is 45? So if you're really good at arithmetic, you're probably thinking about if we just add some integers from 1 to 9 and sum is exactly 45. Oh, I should choose option A, and unluckily that is the wrong answer. So let's think about the arithmetic sequence with a common difference 1. So actually at the very beginning you don't know about the first term, right? So let's just assume the first term is A. And the greatest number, let's assume the number is the capital N. So the first term A, the next term A plus 1, the last term is A plus N minus 1. And the sum, the formula for the sum is you add the first term and the last term times the number of terms divided by 2. So we have 2a plus n minus 1 times n divided by 2 is equal to 45. And let's times 2 on both sides. Just divide n times 2a plus n minus 1 is equal to 90. So n is a positive integer, so as 2a plus n minus 1. And let's think about the greatest possible factor of 90. So that is exactly itself, right? So let's think about, is it possible that n is equal to 90? And correspondingly under this case, you'll find a is negative 44. So what is this sequence? The sequence is like the first term negative 44, you have negative 43, and a lot of terms till 0, 1, and what is the last term? The last term is 45. So the thing is, if you add them up, a lot of terms can be cancelled out in pairs. So the only term left is 45. So yes, it satisfies the restriction. Alright, and you can see the answer is actually D, 90. Okay, let's move on. Question number 2. So the question is, how many subsets of 2, 3, 4, 5 until 9 contain at least one prime number? So first of all, if you never learned about algebra 2, I might explain a little bit about what is set and what is subset. So set is a collection of distinct objects. For example, this is a set comprised by some different numbers. And what is subset? When we say A is the subset of B, we're talking about all the elements in A is also in B, and then we say A is the subset of B. So how to construct a subset? Just choose some elements from the original set, right? And then you just know a subset. And also there's a commonly used formula when you try to calculate the number of subsets. So here, let me write it down. If I have a set, so let's say n1, n2 until nk, they are just k distinct elements in the set. And then the number of subsets can be calculated by 2 to the kth power. And that's really easy to understand because, like, when you try to construct a subset, you need to choose some elements, right? So for each of the element, you can choose to like select it or just ignore it. So for each element, there are 2 options, and in total there are k elements. So the number of subsets is determined by 2 to the kth power. Okay, let's read the question again. So how many subsets do we have contain at least one prime number? So in total you have 2, 3, 5, 7. Yeah, in total you have 4 prime numbers in the original set. And when you see like those kind of words like at least, you probably you'd better think about this question in an inverse way. So how many subsets contain at least one prime number do we have? Equivalent say it's equal to the total number of subsets minus the number of sets that contains no prime number, right? So let's do it. So the total number of subsets is 2 to the power of in total there are 8 elements, so 2 to the power of n minus the number of subsets that contains no primes. So contains no primes, that means you can only choose some elements from 4, 6, 8, 9. So equivalent to say how many subsets do we have as for this set. In total there are 4 elements, so minus 2 to the 4th. Alright, and the next step is just do this calculation. You have 256 minus 16, so the answer is 240. We choose option D. Alright, the last question for today. How many distinguishable arrangements are there of a brown tire, a purple tire, 2 green tires, and 3 yellow tires in the row from left to right? Okay, so there are actually 2 directions for this kind of question. I might interest 2 different ways. So the first way is you first consider all the tires are distinguishable and then divided by the ones we overcounted. So now let's thinking about in total let's first consider you have 7 different tires. So the way the number of ways to arrange them is just 7 factorial. And we overcounted the 2 same green tires and 3 yellow tires, so divided by 2 factorial, 3 factorial, so the answer is 420. Alright, so thinking about another way. So in another way, let's just consider, first let's consider about the 2 green tires and 3 yellow tires. And let me write it down. You have 2 green ones, 3 yellow ones, and you would like to put them in a row. So equivalent to say we have 5 different places, and you need to choose 2 places for the green tires, and the rest of the places are for the yellow tires. So you need to choose 2 from 5. And after that, we already arranged the 5 tires. And now let's choose a place for the brown tire. So as for the brown tire, let's do the counting thing. You have 1 place, 2, 3, 4, 5, 6. In total, you have 6 places for the brown tire. So we times another 6. And after you put the brown tires into it, let's think about how many places do we have for the purple one. So you have 1, 2, 3, 4, 5, 6, 7. So 7 places, right? So we times another 7, and after you do this calculation, you find it's also equal to 420. Alright, so that is all for today, and see you next time.